Hi all, welcome to my channel. In this video, you are going to see how to solve the system of linear equations by using Gauss elimination method. So let us go to the video. So here the problem is being given as solve the system of equations by Gauss elimination method for the following equations. So the equations are x plus 2y plus z is equal to 3, 2x plus 3y plus 3z is equal to 10, 3x minus y plus 2z is equal to 13. So this system of equations we need to solve by using Gauss elimination method. So the very first step is we have to put this equation in the form of the augmented matrix. So augmented matrix is the form of the augmented matrix. Whatever in the first row 1, 2, 1, 1, 2, 1, 3. And then 2, 3, 3, 10, 2, 3, 3, 10, and 3 minus 1, 2, 13. So this matrix is being called as an augmented matrix. Now the next step is we have to make the matrix A in terms of upper triangular matrix. Upper triangular matrix means this is a principal diagonal 1, 3, 2. That's going to be the principal diagonal. So the elements below the principal diagonals, that is your 2, 3, minus 1, you have to make it as 0. Then we will be able to solve the given system of equations. So how to make it to be 0 is by using simple row elementary transformations, we can make all these elements to be 0. So the very first step is I am going to this 2, I have to make it as 0. For that I am using the row transformation. R2 I am going to change in terms of R2 minus 2R1. That meaning is the element row to be changed as I am going to multiply with R1 into 2. So 2R1 and then that should be subtracted from R2. So the second from the second row it is going to be changed as R2 minus 2R1. So 2R1 the sense 2, 4 and 2, 6. So just subtract from R2, 2 minus 2 will become 0. And then from that 3 minus 4 becomes minus 1. And then this is going to be 3 minus 2, 1. And this is 10 minus 6. You will be getting this as 4. So I am writing 1, 2, 1, 3. Only I have changed the element, the second row only. So the second row is now it's going to be 0 minus 1, 1, 4. And the third row I kept as 3 minus 1, 2, 13. Now next step is that we have to change this 3 to be 0. So for 3 to make it a 0, now here my transformation is R3, the row 3, I am going to change it as R3 minus 3R1. I am going to multiply R1 with the 3 and then minus 3 and then to be from that R3 I have to subtract. So what happened? Minus 3 if I multiply minus 3 minus 6 and minus 3 minus 9. So I'm going to subtract from this. So 3 minus 3 becomes 0. So similarly minus 7 minus 1 4. So that is what your second change. So I can able to change this 2 as 0 and 3 as 0. What is left out is minus 1. So to make that minus 1 to be 0, then again let us use the elementary row transformations. Again I can use only a R3 because that element is in the third row. So R3 is going to be R3 minus 7 R2. So multiplying with 7, 14, 7 and then 21, then just subtract 0 minus 0, it will become 0. So this is 0, then minus 8 minus 24. So now if you see, it has come in the form of a upper triangular matrix. That is the matrix A. We have brought in term of a upper triangular matrix. This is the principal diagonal. So all the elements below the principal diagonal become 0. So it is going to be called as a upper triangular matrix. So once we arrive here, we are going to use the backward substitution method. We'll be able to get the value of Z, then Y, and from then X. So now let us see what is the equation you are getting from this matrix. X plus 2y plus z is equal to 3, minus y plus z is equal to 4, minus 8z is equal to minus 24. So minus 8z is equal to minus 24 implies z is equal to 3. And the second equation is minus y plus z is equal to 4. I am substituting for z as 3. So I will be getting y is equal to minus 1. And all these values y and z, let me go and substitute in the first equation. X plus 2y plus z is equal to 3. To get the value of x, I will be getting x is equal to 2. So x is equal to 2 and y is equal to minus 1 and z is equal to 3. So we have found the solution for the system of given linear equations. So getting the value as x is equal to 2 and y is equal to minus 1 and z is equal to 3. To check whether you have done correctly or not, if you go and substitute here, all these equations values will be satisfied. So by using Gauss elimination method, we can solve the system of linear equations. So first what we have to remember is the system of equations to be brought in terms of augmented matrix. Then the matrix A to be made as an upper triangular matrix by using simple row elementary transformations. And after that, by backward substitution, we will be finding the value of z, y, x, like that. That is last value, mid value, and then the first value we are able to find. And this method is being called Gauss elimination method. Now I have done for 3 equations. In my next video, I will explain for 4 equations. If the given equations are 4, then how to solve those given equations by using Gauss elimination method. Keep watching. Thank you. Bye.